As a 7-meter wave pounds the bow, a sharp jolt shudders through the ship. The crew feels a thunderous crack echoing through the steel hull. In the early 21st century, global shipping was evolving rapidly, with ever larger container ships being developed to meet the increasing demands of global trade. Container ships had an average capacity of 6,000 containers. MOL, or Mitsui O.S.K. Lines, is one of the leading Japanese maritime shipping companies. They provide comprehensive shipping services worldwide, transporting energy resources, raw materials, and finished products. To keep up with the booming economy in the early 2000s, they needed larger container ships to add to their fleet. In 2008, Mitsubishi Heavy Industries completes construction of the post-Panamax container ship APL Russia for the container shipping line American President Lines, or APL. Post-Panamax vessels are so large they can't pass through the Panama Canal, and Mitsubishi Heavy Industries are known for producing some of the largest industrial and maritime solutions, making them one of the most respected engineering companies in the world. APL Russia was a state-of-the-art vessel measuring 316 meters long and 45 meters wide that could carry up to 8,110 containers, making it a key player in the era of mega container ships. The vessel's hull was designed to endure the stresses of carrying vast amounts of cargo across turbulent oceans. It was constructed using ultra-high tensile steel, which has superior strength compared to ordinary steel. APL Russia's sister ship Creation was one of the first ships to use this type of steel in shipbuilding when it was constructed in 2007. By using ultra-high tensile steel, Mitsubishi Heavy Industries could reduce the thickness of metal plates, making the ship lighter while still maintaining its strength profile. It was powered by a 2-stroke diesel engine that operated on a simplified cycle of just 2 strokes of the piston. One up and one down that produced massive amounts of power with fewer moving parts, ensuring reliability over extended voyages. The vessel was propelled by a single fixed-pitch propeller. Some ships have variable pitch, which means the blades of the propeller can change angle. Fixed pitch is one of the simplest and most commonly used types of propellers in the shipping industry because it's simple and reliable. The ship was designed to be simple and reliable with a low level of maintenance. Class NK, the leading ship classification society in Japan, conducted the ship's inspection, certification, and technical services to ensure its safety and reliability, and confirmed that it adhered to international safety and design standards in place at the time. In June 2012, APL Russia was chartered to MOL and renamed MOL Comfort. Comfort became an integral part of MOL's global fleet, servicing key trade routes between Asia, the Middle East, and Europe. But as container ships grew in size, so too did concerns over their structural integrity. MOL Comfort, like many ships, faced unique challenges in their design. Larger ships are more susceptible to structural stresses, particularly in rough seas. In May 2013, Class NK conducts a special survey to assess the structural integrity and operational readiness of MOL Comfort. This comprehensive inspection is conducted every 5 years to make sure that vessels remain compliant with international maritime safety standards. The ship's hull is inspected for structural defects like cracks, corrosion, or deformations. They focus on high-stress areas like the midsection, which is prone to hogging or sagging. Hogging happens when the midship rises over a wave while the bow and stern are suspended over either side of the wave, creating an upward bending force in the middle of the hull. Sagging is the opposite, creating a downward bending force in the center of the ship when the bow and stern ride high on the crest of 2 waves. The main engines, auxiliary engines, and propulsion systems are examined to make sure they are in good working order. Bilge pumps, ballast systems, and fuel tanks are tested for leaks or operational issues. They also inspect the container lashing systems, cranes, and other cargo handling gear to verify their safety and functionality. The bulkheads, doors, hatches, and other components are checked to confirm they can withstand flooding or extreme weather conditions. Lastly, the ship's lifeboats, firefighting systems, and navigation equipment are thoroughly examined to make sure they comply with safety regulations. Class NK concludes that there are no major issues with the vessel. In June 2013, MOL Comfort prepares to depart Singapore and make its way to Jeddah, Saudi Arabia. This route is on its regular rotation connecting Asia to Europe, a critical trade route for global commerce. As part of standard operating procedure, a pre-departure stability calculation is conducted to make sure that the ship is stable, balanced, and seaworthy before leaving port. The ship's crew ensures that the total weight is within the ship's load line limits. They take into account the weight of the cargo, ballast water, fuel, and fresh water, as well as the equipment on board. The calculations also determine whether the center of gravity is low enough to ensure stability. They measure the draft, which is the depth of the ship below the waterline, and trim, which is the difference between the draft at the bow and the stern. A proper trim helps the ship move efficiently through the water. Essentially, they run calculations to make sure the ship is well balanced. They then calculate the stress and strain to ensure the ship's hull can handle the stresses from cargo weight and wave action without exceeding safe limits. The forward draft measures 13.45 meters, the midship draft is 12.9 meters, and the aft draft is 13.6 meters below the waterline. These measurements indicate the ship is hogging slightly, where the midship section is higher than the bow and the stern. The ship's officers confirm that all necessary stability and stress calculations are complete and the results are in line with the standards for the ship. The ship has 2,807 tons of heavy fuel oil, 490 tons of low sulfur fuel oil, 139 tons of low sulfur gas oil, and 6,160 tons of ballast water on board. These quantities are calculated to maintain optimal stability and trim during the voyage. The vessel has 4,382 containers loaded. The split between 40-foot and 20-foot containers is the equivalent of 7,041 TEUs, or 20-foot containers, which is the standard unit of measure in shipping. The cargo is distributed evenly to minimize undue stress on the hull. On the 11th of June 2013, MOL Comfort departs Singapore on a westbound journey towards Jeddah, Saudi Arabia. The crew of 26, comprising experienced seafarers from the Philippines, Russia, and Ukraine, works smoothly to ensure the ship is ready for its voyage across one of the busiest and most challenging shipping corridors in the world. Leading the ship's deck departments are the master and his chief officer, leaving the chief engineer in charge of the engine department. Their route is set to take them across the Indian Ocean, through the Arabian Sea and onward to Europe via the Suez Canal. As the ship leaves port, the crew settle into their routine. The chief officer monitors cargo lashings and container stacks. The chief engineer checks the engine and auxiliary systems to make sure everything is functioning without issue. The ship maintains an average speed of 18 knots with the engine running at 83 revs per minute. Weather routing software provides the crew with information about the expected conditions on their voyage, showing strong monsoon winds and moderate to heavy seas in the Arabian Sea. The crew plan accordingly, knowing that the region's summer monsoons can be unpredictable. MOL Comfort is considered well equipped to handle these challenging conditions. But as the ship presses on through the Indian Ocean, it becomes clear that the voyage won't be smooth sailing. The monsoon season is in full force and the seas are building by the hour. On the 16th of June, 5 days into their journey, the wind begins to pick up, reaching 38 knots, which is strong enough to create steep waves that challenge even the largest ships. A swell of 6 to 7 meters rolls across the ocean, slamming into the vessel's bow at regular intervals, but the bridge crew is accustomed to rough seas. To minimize the impact of waves and reduce structural strain, they adjust the ship's engine speed, reducing it to 79 revs per minute, down from the standard speed of 83 revs per minute. The ship's average speed drops from its cruising speed of 25 knots to 17, which will put them slightly behind schedule to reach Jeddah on time, but the master prioritizes safety over speed. The weather routing system issues updated guidance, warning of increasing swell heights along their path. Conditions in the Arabian Sea can be treacherous during the monsoon season, but the officers on watch don't consider the situation alarming. MOL Comfort is a modern ship, equipped to withstand harsh conditions, and its pre-departure stability calculations show no cause for concern. The crew follows routine procedures. The carpenter's soundings are taken each morning to confirm that the ballast tanks and fuel tanks are holding steady. Carpenter's soundings refers to the method used on ships to measure levels of liquid in the ship's tanks, bilges, or void spaces. These checks are critical to detect any changes in water level for each compartment, which could destabilize the vessel. The chief engineer stationed in the machinery control room monitors the ship's systems, including the fuel gauges and bilge alarms. MOL Comfort, like many modern container ships, is designed to flex under the immense loads it carries. This flexing, or hogging and sagging, happens as the weight of cargo interacts with the forces of waves and buoyancy. The ship's designers account for these stresses, but the margin for error is narrow, especially in stormy seas. In the early hours of the 17th of June, the situation is manageable but tense. On the bridge, the 0400 to 0800 watch team monitors the ship's progress. Visibility is reduced because of spray, but the crew are coping and there's no need to alter course. Below deck, the chief officer completes his inspections, noting everything is in order, but he feels like the ship's motion, its pitching and rolling, is slightly off. The chief officer wakes the master and they meet on the bridge to discuss the weather. They decide to alter course slightly to reduce the direct impact of the swell. By approaching the swell at a different angle, the ship will ride more smoothly because a longer section of the hull will be in contact with the wave. The engineers below report that everything is operating within normal parameters and will continue to monitor closely in the rough seas. At 0700, the carpenter performs his daily soundings again. His readings are the same as the day before, but he notices something odd. The forward end of the ship seems to react to the waves differently than the aft end. He reports his observations to the chief officer, but all their readings are in line with their calculations and there's no obvious sign of anything wrong, so it's not considered urgent. And in any event, what do you look for when everything on your checklist checks out the way it's supposed to? What they can't see, what the chief officer and the carpenter can feel and sense, is that the ship's steel hull has stretched to its limits after only 5 years of service. Tiny fractures, invisible to the naked eye, have developed in the ultra-high tensile metal plates. At 0745, the ship is almost 200 nautical miles off the coast of Yemen. A set of waves up to 7 meters high slam against the port bow. The force of the water reverberates through the steel hull and the crew feel a sharp, jarring snap, unlike anything they've experienced before. On the bridge, the chief officer and the lookout immediately sense that something is wrong. The lookout notices the forward end of the ship looks misaligned. In a moment of disbelief, they think it might be an optical illusion caused by the waves. This is something I sometimes see in these stories. Often there's a disconnect between the reality of what's happening and actually recognizing that a disaster is unfolding in front of you. The chief officer calls the master to the bridge. Below deck, the chief engineer stationed in the machinery control room also feels the impact. Moments later, alarms start sounding. The pipe duct keel space running along the bottom of the ship starts to flood. Water pours into cargo hold number 6 and the fuel tanks on the port side. On the bridge, the master orders the chief officer to investigate. Moving swiftly through the underdeck passage, the chief officer finds number 6 cargo hold is already flooded to the height of 1 container level. The side shell plating, which forms the outer wall of the hull, has cracks running along the seams, and the cracks are widening with every passing wave. The chief officer hurries back to the bridge and tells the ship's master what he's found. He shows the master a photo on his phone with a yawning crack on both sides of the ship near the midsection. The master realizes the gravity of the situation. MOL Comfort is not just taking on water, it's breaking apart. The ship's master immediately orders the main engine speed reduced to 45 revs per minute. He needs to reduce speed, which will take some pressure off the ship, but he still needs to keep the speed up enough to maneuver and stabilize the vessel while they assess their options. If he stops the engines entirely, the ship will drift parallel to the waves, which could capsize the vessel in the rough seas. He then orders the helmsman to adjust the heading slightly to minimize the direct impact of the waves. They should aim at a slight angle to the waves. Water continues to flood the affected hold 6, where cracks are spreading. Traces of oil start to appear in water discharged from the pumps. At 0830, the cracks in the hull have widened and the midsection is visibly sagging under the weight of the cargo and the force of the waves. The bridge crew can see that the roll and pitch of the ship in the waves has become erratic. The bow rises sharply out of sync with the momentum of the stern. The crew watch as containers topple from the deck. At 0900, there's nothing more the crew can do, and the master sends a distress signal calling for help from nearby ships. The Yanshan Express, a container ship 24 nautical miles away, responds almost immediately and alters its course to assist. On board MOL Comfort, the crew prepare to abandon ship, mustering at their designated stations and donning life jackets. As the crew readies the lifeboats, the chief officer walks the underdeck passage for a final inspection. The cracks in the hull are no longer just structural deformations. They're gaping breaches, and daylight streams through the side of the ship. At 0945, the master issues the final order to abandon ship. The crew, who are gathered on the starboard side, board the enclosed lifeboat. They have to time their drop into the water, or they could hit containers floating in the heavy seas. The lifeboat, carrying all 26 crew members away from the dying ship, is successfully launched and steams away from the stricken vessel. As the Yanshan Express approaches, MOL Comfort continues to deteriorate. Almost 2 hours later, at 11:36, the crew is safely rescued, and at 11:48, the MOL Comfort breaks into 2 sections, with the bow and stern drifting apart. Salvage teams are mobilized immediately and coordinate with nearby vessels to assess the situation. The next day, on the 18th of June, the salvage teams secure the bow section with tow lines and head toward the Gulf of Oman for recovery. The stern section is in critical condition and starts to tilt forward as water floods the holds. On the 27th of June, the stern section sinks in 4,000 meters of water, 170 nautical miles from the Omani coast. 1,700 containers and 1,500 tons of fuel oil go down with the stern section, leaving behind an oil slick that spreads across the surface. On the 6th of July, a fire breaks out on the bow section. The blaze spreads rapidly, engulfing the remaining wreckage. The Indian Coast Guard joins the salvage vessels, and together they try to extinguish the flames. But the fire gets the better of them, and 4 days later, on the 10th of July, the bow section sinks 160 nautical miles off the Indian coast in 3,000 meters of water, along with a further 2,400 containers and 1,600 tons of fuel oil. The ship was insured for $66 million to cover its hull and machinery. Over 100 lawsuits were filed against Mitsubishi Heavy Industries, alleging that design flaws in the ship's hull led to its structural failure. The International Association of Classification Societies introduced stricter rules for hull strength and longitudinal stability in large container ships. In February 2014, MOL sued Mitsubishi Heavy Industries for the costs to double the hull strength of Comfort's sister ships. The loss of MOL Comfort resulted in insurance claims estimated between $300 and $400 million.